This is a GCSE video which will answer lots of pressing Christmas-based questions. For example, can reindeer fly? How does Santa deliver all those presents? And how fast can he really go? Stay tuned and subscribe. First of all, we need to think about what is Santa? What sort of stuff is he carrying with him? So here's Santa. He's got 9 reindeer according to common folklore. We've got Rudolph at the front there with his red nose. And we've also got Dasher and Dancer and Prancer and Blitzen and all the rest of them helping out Santa just behind Rudolph. So we've got Santa, and I reckon Santa probably weighs, he's a tubby guy, so we've got about 150 kilograms of Santa. We've probably got about 200 kilograms of the sleigh, because it's probably made of relatively light wood, because he needs to fly around with it. And then also, we've got 9 reindeer. Now, the reindeer are probably female, because they've still got antlers. Male reindeer lose their antlers before December, and then grow them again the next year. So these reindeer are probably female because females keep their antlers until March. So 9 female reindeer, according to Wikipedia, weigh about 100 kilograms each. So that's 900 kilograms of reindeer, which gives us a total mass of 1,250 kilograms. Now, the main thing that Santa has to carry around is a big bag of toys. Now, actually, if you think about the bag of toys, then Santa and his reindeer hardly weigh anything at all, because the bag of toys has to have a toy for every single kid in the whole world. So there are 1.9 billion children in the whole world, and approximately 20% of those celebrate Christmas. So he doesn't have to visit everyone, just the ones that celebrate Christmas. So 20% of 1 billion, let's say each one of them gets 1 kilograms worth of presents. That gives us a total mass of 380 million kilograms. Or, if we write it using standard form, 3.8 times 10 to the 8 kilograms. So we've got 3.8 times 10 to the 8 kilograms of toys, and only 1,250 kilograms of Santa and his reindeer. So really, this has almost no effect, and we only really need to look at this. This is so small we can ignore it. So we'll have our total mass of 3.8 times 10 to the 8 kilograms moving forward. So we've got our mass, we know how heavy everything is. Now we need to think about how he's going to get around. Now we know that Santa flies up in the air, so we know he gets gravitational potential energy. And his gravitational potential energy is mass times gravity times height. His mass is 3.8 times 10 to the 8, including all those presents, times 10 for gravity, and I think that Santa probably goes in the clouds, and the clouds, again according to Wikipedia, are about 3,000 meters up, usually. So we've got 3.8 times 10 to the 8, times 10, times 3,000 for the gravitational potential energy, and that gives us a total GPE of 1.14 times 10 to the 13 joules. Now, the other thing he doesn't just go in the air, he also goes around the world, so he moves around the world, so he has kinetic energy for moving, and we know that that's half times mass times velocity squared. Now, we don't actually know the velocity yet, but we do know that velocity is distance divided by time. The distance around the world is about 40,000 kilometers. 40,000 kilometers, it would just get him once around the equator, so he needs to visit every single home. So we're saying that he needs to go around the world about 100 times. So 40,000 times 100 gives us 4 times 10 to the 6 kilometers, and we convert that into meters, so that's 4 times 10 to the 9 meters, so that's kilometers. So we've got a distance. Time, including time difference and things like that, the time that he has is about 31 hours. So 31 times 60 for minutes times 60 for seconds gives us a total time of 111,600 seconds. Remember, time is always in seconds and distance is always in meters. So we can work out the velocity now using distance over time, and the velocity is 4 times 10 to the 9 divided by 111,600, which gives us 35,800 meters per second. Quite fast. Now we can put that back in our kinetic energy equation, and we have 1/2 times the mass of the toys, which is 3.8 times 10 to the 8 kilograms, times 35,800 meters per second squared. And that gives us a total kinetic energy of about 2.5 times 10 to the 17. Now, this is so small compared with this. This is over 1,000 times bigger. So we can almost ignore the gravitational potential energy. It's just like we almost ignored the mass of Santa and his reindeer. We can almost ignore this because it's so small compared with the kinetic energy. So we can have the total energy needed to deliver all those presents is 2.5 times 10 to the 17 joules of energy. Now, just to put that in context, I'll move Santa for a second. The amount of energy we need, 2.5 times 10 to the 17, it looks like a kind of normal looking number down here, but actually that is 2, 5 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 zeros. So if we put some commas in there, that gives us 250 million billion joules of energy. That's how much energy Santa needs to deliver all those lovely presents on Christmas Eve. So that's a lot of energy. Let's take that number and we'll move it forward. So where does Santa get 2.5 times 10 to the 17 joules of energy from? Well, we all know that it gets cold in winter. It gets cold when Santa's delivering those presents. So we also have an equation for when things get cold. The amount of energy that is released when something gets cold. And that is mc delta T. The thing that we're going to talk about in this instance is water, because we know that when it gets cold, it can snow. And so we've got the amount of energy released when a certain amount of water cools down, but then it also turns into snow. So we need the latent heat of fusion there as well, which is the amount of energy released when something converts from a liquid to a solid. So we're going to talk about water. So the specific heat capacity of water is 4,200. The latent heat of fusion of water into ice is 3.3 times 10 to the 6. The mass of water is what we're trying to work out. We need to know how much water Santa needs to turn into snow to get the right amount of energy. We've got the amount of energy up here. And the temperature change, the average temperature in December around the world is about 16 degrees. So the temperature needs to go from 16 down to 0 in order to create some snow. So we want to find out the mass. We've got mass in here twice, so it just takes a little bit of rearranging to get that. So that's E equals M times C delta T plus L. And then we want to find M on its own, so the energy divided by C delta T plus L is the mass. And if you put these numbers all in, then you end up with a mass of water that can turn into snow to provide Santa with enough energy, and that mass of water is about 7.42 times 10 to the 10 kilograms of water. So what you end up with is 7.42 times 10 to the 10 kilograms of snow after Santa has flown by. Now, how much snow is that? Well, we know that density is mass divided by volume. And we want to find out how much snow it is, the volume of the snow. So volume is mass divided by density. And the density of snow, like nice, light, fluffy snow, is about 100 kilograms per meter cubed. So if we do 7.42 times 10 to the 10 divided by 100, we get 7.42 times 10 to the 8 meters cubed of snow. That sounds like quite a lot of snow, but it's also quite a lot of land that it needs to spread over. So how much snow is that when it's spread out over all of the land? Well, if we take that number again, 7.42 times 10 to the 8 meters cubed of snow. We've got 7.42 times 10 to the 8 meters cubed of snow. How much land does that spread over? Well, Wikipedia again can tell us that the approximate amount of land on Earth that is covered by human habitation is about 3.5 times 10 to the 12 meters squared. Now what we want to do is we want to spread this much snow over this much area, but remember, only 20% of people celebrate Christmas, so he's only going to visit 20% of this. So that gives us 7 times 10 to the 11 meters squared that Santa visits. Now if we spread 7.42 times 10 to the 8 meters cubed of snow over 7 times 10 to the 11 meters, that gives us approximately 1 millimeter of snow. So next time you see a white Christmas, next time you get a few little flakes of snow, you know it's because Santa has been flying by and using the energy. Merry Christmas.